Okay, so this will go kind of fast, and I'm recording it now. So obviously for people who aren't able to watch today, this is up later, and this will be the last stats package presentation. And guys, like, just so you know, Christy and I talked about this last week. Just so you're aware, like what I'm teaching you about stats is like really basic. So please don't walk out of here and think, oh, I'm a statistician. No, you're not. Okay. Like, so don't. And if you take Dr. Johnson for 4010, please apologize to her, because like there's stuff that she knows that I don't know, and I'm not good at it. So she'll have to brush you up on some other things, but this will finish up stats. So let's talk about correlation real quick. And yeah, so this is for the people being recorded later. Stop, make sure you have the right set of notes. That should be notes that say something like basics of correlation at the top. And if you don't have them, just stop the video, come back, or come back when you got them, and we'll wait for that. We won't wait now, but we'll wait if you're watching this on a recording. So I'm going to talk about major concepts for correlation, and there'll be this short little unit on correlation. And guys, I'll be honest with you, I haven't looked at this in a while, so I'm going to have to slow down a little bit myself. But by the time we get done, one of the things is you need to be able to recognize the difference between when a t-test or an ANOVA is done versus a correlation. So, and there'll be, when we're talking about that, these two guys will fit into one kind of group, and then correlation is its own different kind of group. So you need to be able to recognize when each is appropriate, or on the converse, when each is being used, you need to recognize the scenario, and I'll talk more about that later. Okay, I'll give you a scatter plot, and you need to be able to tell from the scatter plot just the general direction of the fitted line and whether the relationship is a positive one or a negative one. And guys, this is easy, but there will be people that will miss that. Please don't miss the easy stuff. It's so easy. Okay, you need to be able to describe what a positive and a negative correlation, what that means. Okay, just in very basics. Okay, that's like 101. Okay, so please, that's easy also. I'll give you an R squared value, and you need to be able to tell me what that value, what that value means. Okay, and then I'll give you correlation analysis, and you need to be able to recognize, to interpret it. Again, a lot is the ANOVA, and Christy, you're working on ANOVA. A couple other people are working on ANOVA. Like when you start getting into ANOVA, you'll see, like, it's really all about reading the output, guys. It's really, the process is, I mean, Excel is basically a big calculator. So it's really more important that you understand what you are reading rather than how to do it. Now, I put the how to do it in there really to kind of help cushion up some of that work and that grade, but much more of the points is based around how are you interpreting what you're seeing rather than are you able to do it. Okay, so make sure that you understand that. And that's it. Okay, so let's slow down for just a second. And you're right there in the middle of page 1 on your notes where it says quick review. So remember, just a quick review. And you can just scratch this down. This is not like a question like I'm going to ask like this question on an exam, but to quickly review, t-tests and ANOVA, they both of those, they're designed to look at the differences of one variable that's being measured into or more groups. Okay, so you've got group, and you're measuring intelligence, and you compare average intelligence, or you've got group, and you're measuring vertical leap, average vertical leap, average vertical leap, average vertical leap. Remember, you're comparing group means. You're comparing the means of one group to the means of another group, or another third group, or another fourth group, and so on. So just quick little review, just like that. It's group means. Means of one group, same means of the other group, same, outcome variable of another group. Okay, like push-ups in men and women, or 1 mile run time on, January 1st, July 1st, and December 31st. So this would be an ANOVA. Okay. This is a t-test. Okay, all right. But yeah, you're looking at different group averages of one dependent variable. Okay, simple. Now, a correlation, and this is the basic difference. So you got that little question there, what's the basic difference? A correlation is looking for the relationship between two variables. So you don't have groups. You're trying to establish how one variable relates to the other variable. Okay. So you don't have two different groups of people and the same dependent variable. You've got one variable, one measure, and another measure, and you want to see how they relate. Okay. So it's number and number. You're not looking at two different groups here. You're looking at what effect does, or how does X relate to Y? For example, someone, what's the general relationship between between a numerical grade and the time spent studying? So think about it. Here you go. How is this measured? This is measured in percent, right? I mean, it could be. That's minutes, or a percent. That's a number, and this is time spent studying in minutes. Okay. So you've got one set of numbers and another set of numbers, and you want to see how they relate. Or weight gain related to how much calories are consumed. So obviously, we would think that the more calories you take in, the more likely the more weight you're going to gain. Or reaction, these are just examples. Reaction time related to how much alcohol you've taken in, or blood pressure related to how many minutes of physical activity someone gets in a week. All right. And all of these can be seen using a scatter plot. Nobody go anywhere. I just want to make sure. So yeah, and again, I was kind of friendly there on your notes. When I say friendly, I started creating an answer key for myself for your notes, and I forgot to delete some of the answers. So, like, yeah, you've got there. T-test and ANOVA are designed to look at the differences between groups with regard to one variable. Correlation is designed to examine the relationship between two different variables. Okay, so you're right there in the middle of page 1. Examine the blank, examine the relationship between two different variables. It's not group difference. This is a variable relationship. All right, Abby, you see where you are? You got that? Okay. Christy, you good? Guys, if you're lost, just stop and bark out, because these notes were heavily modified when we got into COVID last year, and so we're kind of still working through the pain of last March. But I did that to make this as simple as possible. All right. Okay. So you've got a question there. What is a scatter plot used for? A scatter plot is used, it allows us to see how one variable is affected by another. It allows us to see, and I even gave you that answer. See how nice I am? I must have just completely overlooked it. But it's used to visualize or see how two variables relate to each other. And we use a scatter plot for two continuous, like, numerical forms of data, and then we plot that on an x-axis and a y-axis. And the x represents one set and the y represents another set of the variables. And then we put down all these dots, and it tells us where each value is, okay? Christy, you okay? You see where we are? Carly, all right? Y'all the brave souls have your cameras on, so. Let's see if anybody else does. I'll scroll. Nope. Okay, there we go. Well done, Corey. Good job. Corey knows how to read the rooms. It's okay. Okay, guys. So again, all this is doing is it's plotting, you know, when someone studies for, you know, 18 minutes, what's their grade? 58. Or when someone studies for 57 minutes, what's their grade? 81. Or when someone studies for 92 minutes, what's their grade? It's a 91 or whatever, okay? And you, so if I gave you all a survey, you know, you might say, well, I spent an average amount of time. I spent 32 minutes and my grade was blah, blah. And you just plot out these dots, okay? And it allows us to kind of see what this relationship is here, what the trend of the relationship is. Now, so when you're looking at a scatter plot and you're right there kind of hanging out at the bottom of page 1, just chill. When you look at a scatter plot, you try and fit a straight line to that data. You know, so for example, right here, your straight line would generally be, well, I guess I'll try and draw it. I mean, it's the best fitted line, okay? Like, okay, so you try and fit a straight line to that data. And you look at the direction of the line, okay? So that's what you're trying to do, is you're just hanging out. You're not writing anything. Just sort of follow along here. You're fitting a line to that data and you're looking at the direction of the line. So yeah, you'd fit a line. You're at the bottom of page 1, just kind of chill. And it's called the line of best fit. And it's designed, and I'm not going to ask you to know all this, to kind of minimize the distance between all the points in the line. And it helps you to see whether, so this is the whole purpose of the line right here, guys. This is all the purpose of the line, is to help you see whether the correlation is positive and negative. Now, if you're kind of tuning in or kind of watching stuff on the side or whatever, I get it. Please don't try and memorize this right here. This is completely pointless if you don't understand that this is the most important thing right here. All right. This is the important part, that the line helps you to see generally whether that correlation is positive or negative. Okay. So there's your line of best fit. Generally, it doesn't have to touch all the points. It just kind of fits best the points. Corey, you all right? Carl's throwing down a rock star or something. What was that? Monster? Bang. Is that what it's called? Bang? What is Bang?
Yeah.
Is that an aggressive type of soda or something?
No, it's 0 calories.
Okay. So is this coffee. Doesn't have any sugar in it. 2 o'clock in the afternoon, 3 o'clock. Okay. So you're just trying to fit that best line. And you look at the direction, all right? And again, you're still there at the bottom of page 1. And you just ask yourself, is it pointing upwards or downwards if you read it from left to right? If you read it from left to right, left to right, like you're reading a book, is it pointing upwards or downwards? If it's pointing upwards, that's a positive correlation. If it's pointing downwards, it's a negative correlation. Okay? And all that means is, and you guys may or may not know this, but all that means is now this is a major concept right here. A positive correlation just means that as one variable increases, the other variable also increases. And a negative correlation just means as one variable increases, the other also decreases. Okay, so this is where you need to be living. You need to be able to read a line and tell me what kind of relationship that is, positive, and also tell me what that means. Ding, 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 ding. All righty. So I think you've got some lines there at the bottom. So which of those two, the left or the right, describes a negative relationship? Someone tell you, you got a 50-50 chance of being right. So which of those describes a negative relationship? The one on the left or the one on the right? What's that?
Right.
That's right. It's the one on the right. Okay. So as you exercise more per week, your resting heart rate is going to decrease. More exercise per week equals less beats per minute for heart rate. That's a negative relationship. The one on the right. Okay. The one on the left is a positive relationship. As the temperature outside goes up, generally your air conditioning bill goes up. Now, interestingly enough, there'd be a flip point in that if your temperature went down a lot, your bills would start to go up again, but don't get into that. That's going to be, okay. All righty. So the one on the left is a positive relationship. Please correct me if I'm wrong. I'm having to slow down to make sure I say that correctly. Okay, but okay. Abby, you good? Good. Okay. All right, we're flipping to page 2. Yeah, and so you've got that stuff there, and we'll just kind of take a break for it. But yeah, that stuff at the top of page 2, where it said that one variable has a positive correlation, and I gave you the answers there. I can't believe I didn't take this stuff out. So yeah, positive. As one variable increases, the other also increases, such as study time and grade, or BMI and calories consumed. Examples of a negative relationship: as one increases, the other decreases. Again, these are two numbers. Okay, it's not two groups. You have number upon number upon number upon number upon number relating to number upon number upon number. You're matching them up, matching them up, matching them up, seeing how that works. Okay. So yeah, like average blood pressure, minutes per week of activity, or alcohol consumed and reaction speed, not reaction time, but reaction speed. So as you consume more alcohol, your speed of reaction might go down. Okay. Carl, good example. I mean, really, that, like, if that was a Monster Energy, I'm sure there have been studies done on Monster Energy drinks or whatever, and reaction speed. Probably after a while, it actually falls back off the other way, or maybe there are more mistakes made. Maybe you don't care about reaction speed, but maybe you overcompensate, put the car in the ditch, something. But yeah, exactly. You may react really quickly, but react poorly. I think we would all agree there are fast reactions that are bad, right? Okay. That's why these days, when you come to ask me about your grade, I go, let me think about that. Right? So it's always smart to stop and think. Okay, so just understand negative relationship, positive relationship. And understand how to read a line. There will be 4 of you guys that'll miss that. It doesn't get any easier than that. Okay, so you're in the middle of page 2. There's a lot, just take a breath break for about a half a minute or half a second. Now we're going to talk about R squared. We're going to talk about describing how the variables relate. So you guys are right there in the middle of page 2 where it says R squared. Okay, and so R squared, yeah, and I can't believe I didn't erase some of these answers. I must have just overlooked it, but yeah, you guys are having Christmas in early this year, but yeah, R squared basically tells you what percent change of one variable is related to the change in another. So I want you to make sure you understand that. You are determining the percent that this variable changes that variable. Study time and grade, or alcohol and reaction speed, or BMI, or calories consumed in BMI. It's a percent. Okay, so get that in your mind because we'll come back to that in a second. And you get that value from doing an analysis, okay, which you won't have to do. I'll just give you the stuff. But watch this, watch out here. Now look, you've got questions there. Now you're right in the middle of page 2. What R squared, and if that might help you to write percent relationship value, that might help you to memorize it to get it, indicates a small relationship. Look at this. Yeah, so a 1% is a small relationship. Okay, here's your small. 9% is a medium relationship. And 25% is a large. And that tells you, so you're kind of boom, boom, boom right there. That tells you the percent of the change in one variable that's related to the change in another. Now think about this for a second. Stop and think. This will blow Corey's mind, probably won't, but okay, so think about that. If a large relationship, if 25% is considered large, that means that there's still 75% of the change that's related to something. Corey arched his eyebrows. 75% of the change is related to something else. Think about that. So if we say that studying time, think about this, Abby, this will be right in your wheelhouse. If we think about studying time is related to grade, and it's a large relationship, and that's 25%, that still means that 75% might be related to a whole bunch of other stuff. Maybe the same person that tends to study a lot is on time for class or attends class, or maybe they tend to get enough sleep, or maybe they, the studying time spent means they're not going out to the bars on Wednesday night or whatever. I mean, it could be a million things, right? So this is why you can't just say, well, it's all because of studying time. You understand how that works? That's why we say correlation does not equal causation, right? I do this every semester. Some semesters I'll have a class at 8, and they're always the class that does better. In every, I'll have back-to-back classes, special pops, 8, 9, 20. And some semesters, the 8 o'clock class is the ones that always score better. Some semesters, it's worse. I have no idea why. My wife has said, well, maybe the 8 o'clock people are the people that get up and get going for the day. Or maybe they're the people who didn't get up and register, and so they fell into the 8 o'clock by accident, and they hate it, and they're halfway asleep. I mean, right? I always used to worry about it, like, because if Abby was in the 8 o'clock and Corey was in the 9:20, well, I would teach Abby's class, and then you and I both know that coming back at 9:20, I probably would remember some things that I didn't tell them at 8 o'clock, or I need to tell them something different. And then like I would customate better at the 9:20. But you know what? I found that doesn't make any difference. I have no idea. I have no idea how to measure it. Like, I have no idea. Some semesters is all the get up and get going people, and the next semester is all the schleps. I have no idea, like none. I've never been able to figure it out. Okay. So again, just understand that when you have a large relationship, that still means there's a whole bunch of mess that's accounting for others. It's true, Carl. There's a whole bunch of mess that's accounting for other stuff. Never been able to figure it out. Okay. People with dogs, maybe they score better. People that bring dogs to class, maybe they score worse because they're paying attention to the dog. I don't know. Who knows? Okay. Okay. And I just kind of, that's just kind of going down through the bottom of that page. I was just spelling that out to you. In the relationship between two variables is found to have an R-squared value of 27. That's what size of relationship. That's a large relationship, and that's 27%. You're at the bottom of page 2 of that relationship is related to a change in the other variable. So just remember that's why we say that correlation does not equal change, is because, or does not equal cause. It's because we can't say, well, that's the only thing. Very rare that you can say that. Okay. Okay. chill for a second. Yeah, and so, you know, when we're doing a correlation analysis, you're not writing in this, don't worry about writing this. When we're doing a correlation analysis, instead of comparing means, you know, we want to know if there's a significant association between the two variables. Is there a predictable, you're not writing this, don't worry about writing. Is there a predictable relationship between those two variables? And we can't tell if the relationship is significant unless we do an analysis. So this is the other side of the correlation, is we have to figure out in the same way whether that relationship is significant, okay? And it only lets us look at these two continuous variables, right? So you've got one like that. Okay, now, here's where it gets easy, and we'll finish out, we'll be done. So you're flipping to page 3 here, and you've got a sample analysis output. And there are really only 2 variables on here that matter. So I want to make sure you guys know where they are. It's the R squared, that's right there. And it's the significance, that's right there. Now, here we are, we're here at, 26 minutes into the slideshow or whatever. And I'm telling you right what's important. And some of y'all, I guess maybe, you'll get to this on the exam and you will see all these numbers and you'll start crying. And you will. And I've done it. You're like, what the crap am I supposed to do with that? Like, so I'm telling you what to pay attention to. All right. This tells you the size of the relationship. And really, this tells you if it even means anything. Okay. When I say it means anything, whether it's significant or not. And so this right here, for example, yeah, yours is a little bit different. You have different numbers on there, but it's the same thing. So this right here tells us, this on the screen tells us that we have a 25% relationship between VO2 max and squats to fatigue, and that is a significant relationship. Okay, so on your guys's, like on your output there, somebody be brave. Tell me what the significance of the relationship is. Now watch it. What's the significance? Is it significant or not? Don't say, well, is it significant or not? Well, we're using alpha of 0.05, by the way.
Not significant.
No, that is significant, right? Am I saying that right, Hunter? Christy, you got me there?
Because it's below.
Less than 0.05.
Yeah.
Yep, I got it. I got it. Thank you for being brave. You got to dial this in. I get it. 100% get it. Okay. It's a mind job and you just got to get it. So if it's less than the alpha, then that means that the results you got had a 95% chance of not happening strictly by chance or by random. Okay. Remember, you're going to get the results no matter what. You just want to know what's the odds that this happened by accident. Okay. And what's the size of that relationship? Is that on y'all? Is that small, medium, large, or huge? It's like large. Okay, yeah, it's large. That's a large. Yeah, that's a large relationship. And again, on y'all's paper, not on the screen. On y'all's paper, what percent of the change can be explained by the change in the second variable? 64%. Okay, you got it. So that's, y'all just have to be able to interpret that. That's it. Like you don't need to be able to run the rate. What's up, Corey? You okay? You're unmuted. Okay.
Oh, my bad.
No,
I
you're
meant
good.
to hit the
Just want to
camera.
make sure you didn't have a question. It's fine. Okay. So guys, that's going to do it for correlation. Simple stuff. Now you don't got it. All right. Trust me. Because like Corey knows. Corey and I had a battle royal last Thursday, right? Or whatever, right? It's okay. It's all right. Christy got him straightened out, either Christy or Hunter or both, right? That's right. It's fine. Yeah, he came back and he's like, I'm so sorry. I was like, it's okay. It's fine. No big deal. Okay. So I'm going to stay here for another however long, 30 minutes is fine. So if you have questions about your t-test stuff or whatever, I will answer those. So you are free to go otherwise, but I will stay here for 30 minutes and hang out with you guys. All right. And I will post this stuff to D2L, this link. It'll be up by the middle of the evening tonight. Okay.